Hey guys, in this video we're gonna learn about the quick sorting algorithm. And this is a very important sorting algorithm because like merge sort, it has a time complexity of n log n, which makes it a really popular alternative to merge sort and something that you should probably learn or at least grasp the concept of. So without further ado, we're just gonna get right into it. So over here we have an unsorted list of numbers, right? Starting with 5, ending with 1. And so essentially the idea of merge sort or quick sort is that you pick a pivot and then to the left of a pivot you populate it with numbers that are less than the pivot number, and to the right of it you have numbers that are greater than the pivot number. So for example, over here, let's say the pivot is always going to be the number in the middle of the array. So over here we have the number 3, and so in fact what we can do is instead let's move the 4 over here, and you'll see why in a second. So let's say we chose 3 as the pivot number. We can switch it with the last digit, so we get 4, 5, 1, 2, and 3. And remember that this is the pivot. And so what we do is that we have a left pointer, right? So if I put an arrow over here, call this L, and we have a right pointer. So what we do is with the left pointer, we keep moving to the right and we stop when we get to a number that's bigger than our pivot, right? Because if it's on the left side and it's bigger than the pivot, then we want to move it over to the right side. And then what we do is we look at the right pointer and we keep moving it to the left until we hit a number that's less than our pivot, because we want since it's on the right side and it's smaller than the pivot, we want to move that over to the left side. And we keep doing this until the left pointer is actually past the right pointer. So over here we can see that our left pointer points to the number 4, which is bigger than the number 3, so we stop there. Our right pointer points to the number 2, which is smaller than the number 3, so we stop there. And what we do is we switch these numbers. So if we switch them, we get 2, 5, 1, 4, and 3. And so remember, 3 is still our pivot. We move the left pointer to the right one spot, and we move the right pointer to the left one spot. And so if we notice what happened here, before the 4 was ahead of the 2, even though it was bigger, now that we've switched them, we can see that the 2 is ahead of the 4. And so now if we do that one more time, we can see the left pointer. We keep moving it to the right until we hit a number that's bigger than 3. And in this case, we can see that 5 is greater than 3, so we stop there. And the right pointer points to the number 1, which is actually smaller than number 3, so we stop there. So what we do here is we switch the 5 and the 1. And so what we get is that we get 2, 1, 5, 4, and 3. Remember that 3 is still our pivot. So we can see now that before 5 was ahead of 1, but now 1 is ahead of 5. And then what we do is we move the left pointer to the right once. So we have the left pointer over here, and we move the right pointer to the left once. So we have the right pointer over here. And so because of this, we can see that the left pointer is now past the right pointer. So we stop at this iteration of the algorithm. And what we do is we switch our pivot with the number that's being pointed by the left pointer, or the left pointer essentially. So what we do is we swap these, and we get 2, 1, 3, 4, and 5. Notice how the pivot's now where the left pointer was, and the number that was pointed at by the left pointer is now at the end of the array. And so now because of this, we know that these two numbers are smaller than 3, and these two numbers are bigger than 3. And so now we continue that same process, except we do it on the left half of the array, and we do it on the right half of the array. So let's start off with the left half of the array. We can see that, say we choose the number 2 as our pointer, we can see that 2 is, we move it to the end, correct? So we do, if I put an arrow over here just so that we can separate it a little, we have 2 and 1. This is our pivot, so we move it to the end, and we get 1, the numbers 1 and then number 2. And we can see that the number 1 is our left pointer, and it's our right pointer. And so obviously, since it's the left pointer and the right pointer, we can't do anything there. And so we stop over here, and we can see that because of this, we've ensured that all the numbers that are less than 2 are to the left of the number 2. And so we can see that the number 1 is now ahead of the number 2, and it's in sorted order. So if we bring that back to the original array, or we see how that fits in the original array, we get 1, 2, 3, 4, and 5. And now we know that this part of the array is sorted, and we just need to look at the second part of the array. So if we look and we make a little arrow over here and we see the numbers 4 and 5, say we choose a number 4 as our pivot and we swap it with the number 5. Obviously it's already in sorted order, but we want to go through this example in the same way that our Python, or maybe Python, maybe in another programming language, our quicksort algorithm will go through. So we swap it to the very end, so we get 5 and 4. And so over here we can see that 5 is the left pointer and the right pointer. And since it's bigger than the number 4, we swap it. And so we get, once again, the numbers 4 and 5. And so if we put that back in the original array, we get the array 1, 2, 3, 4, and 5, and we can see now we have a sorted array. I hope that was helpful. If you have any questions, make sure to leave comments in the section below. Other than that, have a nice day and bye.